Hi friends, in this video we are going to see about Warshall's algorithm which is present in unit 3. Here Warshall algorithm is used to find the transitive closure of a directed graph. So first is transitive closure. You should know what it is. It is nothing but, for example, from one vertex to another vertex, if you have any paths, then it will be mentioned with 1. If you don't have, then it will be mentioned with 0. So by using intermediate nodes or direct nodes, if you have any paths, then it will be called as transitive closure. So moving from one vertex to another vertex, if you have path, that finding is called as transitive closure by using intermediate nodes also. Next, second point is the graph in which all the edges are directed are called digraph. So if you have a graph, then it is directly connected with another node, then it will be called as digraph. For example, from A to B you have direction, so all the edges in a particular graph is directed. If you have that edges, then it will be called directed graph. So digraph is nothing but the graph which have all the edges. Adjacent matrix is nothing but you have a graph, for that you are supposed to form an adjacency matrix, that I will show in the next step. For third point is transitive closure. It is nothing but from point one node to another node, if you have intermediate nodes, that also can be opened, and if you have path, then that will be called as transitive closure. So now we will see example problem for Warshall's algorithm. So this is a graph. So it consists of 4 nodes, that is A, B, C, D, and it have direction A to B and B to D and D to C and D to A. So for this you are supposed to form an adjacency matrix. This is what adjacency matrix. This is also called as a matrix of zeroth position. So you have 4 nodes. So you are supposed to write the nodes in horizontal for column and also row. So for column A, B, C, D and row A, B, C, D, these are the nodes you are supposed to write in the matrix. From that, so if you have direct connection between A to A, then you can mention the value as 1. If you don't have any edges connection between the particular node to node, then it will be called that will be mentioned with 1. So for here I don't have direct connection A to A, so I am mentioning 0 here. So here it is A to B, so if for A to B I am supposed to mention 1, and A to C I don't have connection, then it is 0, and A to D there is also no connection, direct connection, so it is 0. For B, from B to A I don't have any connection, from B to B also don't have connection, and B to C also don't have connection, so B to D I have connection, so I mentioned with 1. For C I don't have any connection, direct connection, A to A, C to A, C to B, C to C, C to D I don't have connection, so I mentioned with 0. Next is D to A. So I have connection with D to A, so it is 1, and for D to B I don't have connection, so it is 0, and D to C I have connection 1, and D to D I don't have connection, it is 0. So this is what adjacency matrix, and it will be considered as 0th R. This is what the first step. So adjacency matrix was formed. Now we are supposed to consider A as an one intermediate node. I'm finding for the next root. If one root is clear, that is intermediate node is opened, then what will be the next path that you are supposed to find between the connection between the nodes, each nodes. So for this, if you have any extra values from the first step, then you are supposed to mention with box or some other color in the matrix. So again you are supposed to mention all the matrix, all the nodes in the matrix A to D, and here also A to D, and here what are the nodes which is already available with value 1, that you are supposed to mention as it is. For example, 1, this one, and this are supposed to mention as it is. Now we are supposed to calculate remaining nodes. So here it is R, A node is intermediate node. If I open this particular node, then how would will be the answer that we are supposed to find. So from A to A I don't have connection, so it is 0. From A to B I have already connection. From A to C I don't have connection if intermediate node is A. And A to D also no don't have connection, so it is 0. Next B to A. So for B to A I don't have any connection, even though A intermediate node A is opened. And then B to B also don't have, and B to C also I don't have, and B to D I have already one, so it is mentioned 1. So for C to A, so it is opened, I don't have connection. C to A, so it is 0. C to B, C to C I don't have any connection, so it is mentioned with 0. Next is D to A already mentioned, it is 1. Now D to B, so from D node to B through A can be moved. So D is moved to A, it is opened, so I can move to B. So here I mentioned with 1, and then these two things are already available. Now next we have to find the next intermediate node, next path, that is transitive closure. So here node A and B are intermediate node, it is opened now. So now we have to check. So already what are the nodes are available with 1, that have to be mentioned as it is, and remaining things we have to find. So A to A we don't have, and A to C we don't have any connection, so it is 0. And A to D, from A now we are B node is opened, so from A B to D I can move, so I mentioned with 1, and it is mentioned with within the box. Next B, so from B I can't able to go to A, so it is 0. From B 0, from B to C 0, and B to D also already available, so it is 1. Next is C to A, it is 0. C to B, C to C and C to D is 0. Now